can't. But it is. It's paradoxical, and yet it works.
Hello Ziad. So figure 4 shows a uniform beam supported by two light cables, AB and AC, which are attached to a single steel cable from a crane. Beam is stationary and in equilibrium. So equilibrium, as soon as you hear those, it's the first question anyway. Two conditions, resultant force is 0. So the force is up equals forces there, and forces to the left equals forces to the right, etc., etc. And then resultant moments is 0. So clockwise moments equals anti-clockwise moments about any point. So statewide is meant by the center of mass. So you've got that, that's fine. Okay, so this question is okay. So let's move on to the next bit. Okay, so let's look at this. Explain why the center of mass of the beam in figure 4 must be vertically 0. So it says it must be vertically below. Oops, vertically below. Why must it be? So first of all, what's happening? It's in equilibrium. So what do we know in equilibrium? As you said, the resultant moments is 0, or there's no movement in any way, or more importantly, there's no rotation or swinging, probably the best word, or swaying. So what have you put? Theta s equals theta is the pivot. I'm not sure what you mean. I've just got your picture here. Right, so, and you should know anyway that whenever you're suspended by a point, the center of gravity always falls directly, vertically underneath the point, because when you're suspended in an equilibrium, you're not moving sideways, you're not rotating, whatever. So therefore, the center of gravity is not creating a moment, because the perpendicular distance from the center of gravity, or the line of the force of the center of gravity to the pivot, should be 0. Okay, so I'm not sure. Yeah, I think you just missed out the bit. Maybe there's not no rotations or swinging. Right, let's look at the next bit then. So the weight of the beam is 1200. So you've got that. That's in newtons. Okay, and then it says calculate tension T1 in cable AB, T2. So what we got, and you sort of started drawing it. So that's T2. That's T2 cos 37. And this one is T1 cos 53. Okay, and it's also got horizontal components. So there's this one is T1 sine. It's got to be the other one, sine 53, and this one is T2 sine 37. Right. So what we can do here, this is not a moment's question. This is now resultant force is 0. So resultant force is 0. So let's do the first one. Let's say forces upwards equals forces downwards. So the forces upwards is T1 cos 53 plus T2 cos 37 is equal to 1200. 12,000, sorry. Okay, now we've got an issue because we've got two unknowns, T1, T2. So what can we do? Let's look the other way. So forces to the right equals forces to the left. Okay, so forces to the right, so T1 sine 53 is equal to T2 sine 37. So you got two formulas. Now, if you look what you've done, you got the first bit correct, and T1 cos 53, T2. So you got that bit, and then you worked out cos 53, cos 32, and you sort of got stuck, which is sort of, that's okay. So you've only looked vertically, but don't forget it's in equilibrium vertically and horizontally. Let me just check cos 53 if you got that correct. Okay, so let's just put this in. So this is 0.6 T1. I'll trust your calculations. 8 T2 is 12,000. All right. But if you look at in this case, well, what have we got? We can now rearrange for either T1 or T2. So let's just do it for T1. So T1 is equal to T2 sine 37 over sine 53. Okay, so I can now work out T1 in terms of T2 and then sub into the other one. So sine 37 divided by sine brackets, looking at brackets, sine of 53, close brackets. So that gives me 0.75. Okay, so we could sub that into here. So you've got 0.6 multiplied by 0.75 T2 plus 0.8 T2. Let's put these in brackets, it's looking messy. Is equal to 12,000. Okay, so if we work that out, so that times 0.6 is equal to 0.4. So that's 0.45 T2 plus 0.8 T2 is equal to 12,000. So if I just add 0.8 to that, okay, and then 12,000 divided by answer, so you get T2 to be 9,583 point something. So T2 is 9,600 newtons. And then now that you've worked out T2, sub into any formula you want. You could probably sub it into here really quickly. So times by 0.75. Okay, so T1 is equal to 7,187, so 7,200 newtons. Okay, hopefully that makes sense. Just don't forget you got to resolve vertically and you got to resolve horizontally.